EQ number 26. So we're talking more about chemical reactions. So far you've learned how to name chemicals and chemical reactions. You've learned how to decide product versus reactant. You've learned how to write out chemical reactions, and you've learned how to balance them. So our next step then is going to be to start assigning different types of chemical reactions that exist. We're going to talk about 5 different types. There are plenty more than 5. We're just going to pick the 5 most basic and talk about those. So your EQ, as it says right here, EQ number 26, what are 5 different types of chemical reactions and a brief description of each one. So you guys should have, I believe, copied down a chart that looks somewhat like this. I hope, anyway. So we've got the 5 types listed over here, and then a definition, and then we're going to write out kind of like a generic equation for each one, which will help you figure out how to identify them when it comes to actually looking at chemical reactions and deciding what type it is. So I'm going to zoom in a little. We're going to talk about synthesis reactions first. Okay, so synthesis, when something is synthesized, hopefully you're thinking that it's made, right? When something's synthesized, it's, you know, you're taking pieces and putting them together to make something bigger, okay, to make one thing, really is the way that synthesis reactions work. So the definition is going to be, actually, last time I did this, I accidentally wrote on my dining room table with Sharpie, and now I can't get it off. So I need to put a piece of paper under this so that I don't, again, write on my table with Sharpie to the point that I can't get it off. Okay, there we go. So definition of synthesis. So it is 2 or more elements, could just be single elements, or compounds. Sorry for being left-handed again. So 2 or more elements or compounds. It's when 2 or more elements or compounds combine to make one substance. Alright, so in synthesis, you're taking 2 or more smaller things and combining them to make one large substance or one large compound. Okay? Oops, should have an E at the end. So 2 or more elements or compounds combined to make one substance. And again, I'm just going to give you a very generic equation. So we're going to use letters, and then we're going to use colored circles. I think that's the easiest way to do this if I have enough colors. I think I do. So a generic setup would be A plus B makes AB, right? We would just take them and put them together to form a just a bigger substance, but it contains our reactants, right? It's like ingredients. Hold on. I have to move the dog's food again because he sounds disgusting when he eats and I can't handle it. Move over here, buddy. Okay, I'm back. So if you are more of a visual kind of person, if you have color, you know, pens or highlighters or something, you could also do this. So if we represent the first element as a red dot, I'm going to break out some other colors here, plus, I don't know if you're going to be able to tell, if you're going to be able to see this or not. The second one as a yellow dot. Oh yeah, you can see that. So in a synthesis reaction, we would put those together, and obviously we would just make a compound that contains both of them, but they'd be together. in one substance. Okay? So far so good, hopefully. Decomposition is the next one. And hopefully you can use some context clues from synthesis. Synthesis is taking smaller pieces and making one thing. What do you think decomposition is? Hopefully you're thinking it's when you take one thing and break it down, right? You decompose. When something decomposes, it breaks down. You take one thing and break it down into smaller elements or substances. So this one, and it doesn't necessarily have to be one compound, I guess. It could be, you know, two compounds that are all breaking down into the pieces that form them. So what I'm going to do is put compounds. I'm going to put compound. All right, hopefully you've seen this in like English or something. I'm just going to put the S in parentheses at the end, so you know that it could be more than one compound. It's almost always just one, but it could be more than one. So compound or compounds break down. Compound or compounds break down into simpler substances. I don't want to just say elements because they can break down into other compounds, they're just smaller. So I'm going to say substances instead. Alright, so compound or compounds break down into simpler substances. Pretty simple definition. If we are going to write a general equation, I'm also giving you some time to write that. I don't know if you need time or not. I am so sorry. I am tired. If you want to know what time this actually is, this is the week before Christmas break. Today you took your 7th period exam. So that's the moment I am in right now. But clearly you are watching this much later than that. So I hope your semester's going well so far. Hope you all did well on your exams and you got the grades you wanted. Alright, let's continue. So, this is going to be the exact opposite of what we just put for synthesis. We're going to have a bigger substance, and it's going to break down into the pieces that formed it. So AB breaks down into A plus B. And obviously you can probably guess what the visual picture is going to look like. So on this side, we're actually going to have the two joined together, right? Because we're going to start off with a bigger substance. And then that is going to break down into the two smaller substances. And we're going to do some examples of these after we fill in this whole chart, so you can see how to apply this information, okay? Those are the two easiest. Actually, these are all pretty easy to recognize. The problem's going to come next week when you have to actually write, you have to guess, you know, what the product is going to be, but we're not going to talk about that right now. Let's just focus on types of reactions. So next one, just checking to see if I'm writing on my table. I'm not. Is single replacement. All right, single replacement. So here's what happens in single replacement. Let's write out the words first, and then I'm going to give you some ways to maybe better remember this. So this is, this happens when one element, sorry, ignore that. One element replaces another. One element replaces another in a compound. Hopefully you can read that. That says compound. I'm going to rewrite that. That looks awful. C-O-M-P-O-U-N-D. That's what that says. Compound. Okay, one element replaces another in a compound. So I like to call this, and you can make a note if you want to, maybe slightly, I don't think it's school inappropriate, you guys are teenagers. I like to call this, and actually it wasn't me, my first students I ever taught in chemistry came up with a name for this to help them remember it. They called this, I'm going to put a little star over here, the home wrecker. Alright, and you'll see why. They called it the home wrecker reaction. So here's what happens in a single replacement reaction. Okay, so if we're going to write it out first. So we'd have something like A and B are in a compound together, and C is just an element chilling by itself. Well, on the other side of your arrow, okay, after the reaction, what would end up happening is you could say A, it could be A or B, but we're going to say A is actually paired up with C now, and B is the one that's alone. So notice C just went in and kicked B out of the relationship and took its spot, hence why we call it the home wrecker reaction. It's a helpful way to remember it. Okay, so hopefully no one's offended by that. Hopefully you find it to be helpful. So to draw our little visual representation. So let's say we've got, actually I'm going to draw this one a little bit differently than the other ones. So let's say on this side, we'll put red and yellow together. And I need a third color. Let's hope this one shows up. It's a blue, but it's a fine point marker, so hopefully it works okay. You see that? Yeah, that should work. Okay, so on this side, red and yellow are together and blue is alone. And on this side, I'm actually going to draw two different scenarios just so you can see that, it doesn't have to follow this exact pattern. As long as one gets kicked out and blue takes its place, it's okay. All right, so I'm going to draw two different products. So in the first scenario, you would have red and blue together, okay? And yellow would be by itself. All right, but there's another option. What do you think the other option could be? Hopefully you're thinking that it could actually be that blue kicked red out instead of yellow, right? So now blue and yellow are paired up, and red is by itself. Either one is possible. It's all going to depend on which one this one is most like. Okay, and we'll talk about that more next week, but both are possible, right? Just so you are aware. It's not always going to be, that the second one gets kicked out by the one by itself. Okay, either option is possible. All right, so hopefully so far so good. Let's move on to double replacement. All right. A name for the double replacement reaction that might help you. You could think of it as if you've ever seen that, it's a terrible show, Wife Swap, where, you know what I mean, where a wife from one family goes and lives with the other one, and then a wife from the other family goes and lives with that family. Super creepy show, because people are weird that try out for that show. But if you can remember this as the wife swap reaction, this might help you out a little bit. All right, so double replacement, maybe you can use some context clues from single replacement and figure out what happens in a double replacement reaction. So this happens, so how do we write this? Let's say different atoms / ions, because polyatomic ions can do this. Different atoms / ions in two compounds trade places. And if the words sound confusing, it's okay. I think the picture is going to be far more useful anyway. All right, so what's going to end up happening is you're going to have two compounds as your reactants, and then you're going to have two different compounds as your products. But all that's going to happen is that one atom from each compound, they're just going to swap places. All right, so let's draw the picture. Again, I think the picture will be a little more useful for you. So we're going to say, let's say that A and B are together and C and D are together. Okay, and we put them into a chemical reaction. Well, on the other side, it would be like, you could say something like A and D are now together, and C and B are now together, right? And the order that we're listing them in right now doesn't necessarily matter. That's why I'm kind of making it a little bit random. Okay, so as long as they're with a different atom or ion on the other side, and actually in this case they'd probably all be ions, but as long as they're with something different on the other side, it's a double replacement reaction. Okay, so let's draw some pictures. This one should, again, there's going to be more than one answer in the end. So we're going to draw it kind of like we do this one. We have two different product choices. So let's say we've got, let's stick with yellow and red together, plus, I'm going to have to use the black marker as a color this time. Hopefully you can see the difference between the blue and the black. And then blue and black together. Is there a difference? Hopefully that's enough of a difference. Maybe if I zoom in on it. Yeah, you should be able to see that difference. Use different colors if you're following along and using colors. Okay, so we'll draw our arrow. That's a terrible arrow. I have to redraw that, sorry. A little better. Okay. So on the other side, a couple of options. So right now, if red and yellow are together, it just means on this side, red and yellow can't be together. They would have to switch who they're paired up with. All right, so we put red, and now we know red would have to be with either blue or black. All right, so I'm going to make it red and black. And then that means the only other option would be yellow and blue, right? So I'm going to put blue and then yellow. The order of the colors really doesn't matter. Okay, I'm just trying to make it kind of random. Just so you don't fall into the habit of thinking it always has to go in this exact order. Okay, so there's your first option. But we know obviously that's not the only combination we could come up with. So let's say you could also have red and what would be the other option red could pair up with? Hopefully you're thinking blue, right? Which would mean our other option. Sorry, it kind of keeps getting blurry and then focusing. Would be, if red and blue are together, then that would leave black and yellow, right? And again, the order doesn't necessarily matter. It's just for you to see that there's a couple of different options that could happen. All right, but in either case, whoever they were paired up with over here is not who they're paired up with over here. That's what I want you to get from that. Okay? That's a double replacement reaction. And the last one, which as much fun as I'm having drawing colored circles. We don't need colored circles for the last one. Combustion is a very specific type of reaction. So I'll give you the definition and then I'm going to give you kind of the most generic of a reaction I can give you, but it's not too difficult to recognize once you see what you're looking at. Okay, so this is when, so you have a hydrocarbon. If you don't know what a hydrocarbon, you probably don't know what a hydrocarbon is, but it's a combination of two elements. What two elements do you think are combined in a hydrocarbon? Good, hopefully you're thinking or saying it's just hydrogen and carbon combined. Any combination of carbon and hydrogen, we can call a hydrocarbon. Most of our fuels, propane, ethane, butane, methane, hexane, all of those are hydrocarbons, okay? So it's when a hydrocarbon and oxygen, and we've seen plenty of these before. I've used these as examples a billion times. It's just we never knew to call it a combustion reaction. So it's when a hydrocarbon and oxygen react to form, and here's the easy part, they always form the same products every time. They always form carbon dioxide. Sorry for my hand being in the way again. They always form carbon dioxide and, I'm running out of space, water. Alright, so hydrocarbon and oxygen react to form carbon dioxide and water. Always what you get, every single time. Alright, the only thing that is possibly going to change, or the only variation that you'll end up seeing in this reaction is the hydrocarbon. The hydrocarbon can be any combination of hydrogen and oxygen. I'm sorry, hydrogen and carbon, but oxygen's always the same, carbon dioxide is always the same, and water's always the same. Never any different. So these are pretty easy to recognize once you understand what you're looking at. All right, so again, hydrocarbon and oxygen reacts to form carbon dioxide and water. So again, I said this one's not going to be super pretty. And I'm going to actually write in a thinner marker to make sure I can fit it all in this box. So the most generic I can go with this is a hydrocarbon. Alright, and underneath it, I'm going to put, actually I could do this in red, maybe it'll stand out a little more. So hydrocarbon would just be C, any number. Okay, so I'm just going to use X, and then H, any number. Okay, any combination of carbon and hydrogen. So hydrocarbon plus oxygen. How do we have to write oxygen in a chemical reaction? How does it have to exist? What do you have to remember about oxygen? Hopefully you're remembering Brinkelhoff. It's part of Brinkelhoff. Oxygen must exist as O2. So it's a hydrocarbon plus oxygen, O2, gives carbon dioxide. So hopefully you know the symbol for carbon dioxide, CO2 plus water, H2O. Right, that's always going to be your setup for at least the kind of combustion reaction we're talking about. There are other types of combustion reactions. These are the only ones you have to worry about at the moment. If you opt to take AP Chem next year, you'll learn that there's a lot of different types of combustion. There's not just carbon combustion. There's sulfur combustion. There's a lot of different ways that combustion happens, but we're specifically just talking about hydrocarbon combustion. All right, so you just have to be able to recognize that as a combustion reaction. All right, so what I'm going to have you do now, you don't have to write these. I wouldn't actually, it'll take you too long. I have some examples of you to look at. I scratched out the answers, but we'll go ahead and fill in the answers as we go. So I'm going to give you reactions. They're already balanced because I'm not really testing your balancing skills at the moment. I want you to tell me what kind of reactions these are. So at the top it just says, use S to label for synthesis, D for decomp, SR for single, DR for double, and then C for combustion. All I want you to do is look at these and tell me what kind of reaction is happening. Alright, so we'll do these ones together, and then I'll leave these ones, there's another column over here. We'll do these ones together, and then I'll shift it so you can look at these. You guys can pause it for a second, make sure you can answer them, and then I'll go over those ones too, and then I have this whole second page that you can practice as well. Alright, so if we are going to label these, again, they're already balanced, so don't worry about balancing them. I just want you to be able to pick out what kind of reaction is happening. So if we have 4P plus 5O2 makes P4O10, what type of reaction does that look like? And I'm actually, let's gonna grab the one I just made out from under here, sorry. So I can show you the one that matches most, right? Two smaller substances coming together to form one, so that would be a synthesis reaction. Next one, it's got 2 C2H6 plus 7 O2 gives us 4 CO2 and 6 water. Notice this right here is a hydrocarbon, right? Combination of carbon and hydrogen plus oxygen gives CO2 and water. What kind of reaction must that be? Good, hopefully you said combustion. Next one, we've got 2 Al2O3s breaking down, hint, hint, breaking down into aluminum and oxygen. So what type of reaction is this? Good, hopefully you said decomp. And then the last one on this side, so you've got chlorine by itself, right? And we say chlorine by itself. It is Cl2, but we know that's just how chlorine must exist by itself. We still consider this a single element. Okay, even though it's diatomic, we consider it a single element. So chlorine plus NaBr, right, sodium bromide. And then look what happened on this side, the sodium's with the chlorine and the bromine's by itself. And again, bromine has to be Br2 just because it's part of Brinkerhoff. So chlorine was by itself, these were paired up on this side, bromine's by itself, sodium and chlorine are paired up. So that can only be what kind of reaction? Good, single replacement. I'm going to shift these over. You guys might want to pause it. These are not difficult. You won't have to pause it for very long. Just pause it for a second. Make sure that you can answer these ones. And then I'll quickly put the answers for these. And then we'll do this 2 more times just to make sure you can identify these on your own. All right, so pause it, do them, and then unpause me. All right, hopefully that went well. Hopefully you got Mg plus O2 gives MgO is a synthesis reaction. HGO gives Hg plus O2. That is a decomposition reaction. A hydrocarbon plus oxygen makes CO2 and water. Easy to recognize is combustion. Then here, hydrogen plus nitrogen makes NH3, right? H2 plus N2 gives NH3. Synthesis. Only option, right? Hopefully you guys are finding this to be a very simple day. I hope. Anyway, I hope. Next one. So again, go ahead and pause me. Make sure you can do these, and I'll fill the answers in as soon as you unpause me. All right. I'm going to put this paper under it so I don't write on my table. So Na plus Br2 gives NaBr. Hopefully you got synthesis. So here we've got HGO, so hydrogen and mercury together, chlorine by itself. And then on this side we've got hydrogen and mercury and chlorine together and oxygen by itself. So that could only be single replacement. Notice here, this one looks a little bit different than the simple ones we've been doing, but it's no more difficult to point out, I don't think. So we've got KClO3, we know that's potassium chlorate, breaking down into KCl and O2. Again, keyword, breaking down. One large substance breaking down into 2 smaller substances. Has to be decomposition. And then down here, this one's kind of a long reaction, but notice barium chloride, right? BaCl2. Barium and chlorine are together. Sodium sulfate. So the sodium and the sulfate are together. And then on this side, the sodium and the chlorine are together. The barium and the sulfate are together. So notice all they did was swap who they were paired with. So hopefully you have put that is a double replacement. Now you've seen an example of all of them. So I'm going to put these last 3 up. Pause me. Make sure you can do these. Okay, so here CuCl2 plus H2S, right, that's copper 2 chloride plus hydrosulfuric acid, makes copper 2 sulfide plus hydrochloric acid. Notice the only thing that happened is they just switched who they are paired up with, so double replacement. Next one, C6H6, hydrocarbon, right, hydrogen and carbon plus oxygen gives CO2 and water. Again, it's already balanced, that's what you know what all those other numbers are. but hydrocarbon, oxygen, carbon dioxide, water is combustion. And the last one, S8 plus F2 makes SF6. So sulfur plus fluorine makes sulfur hexafluoride. Just a simple synthesis reaction. And that is it. This is kind of a short lecture. So if you have any questions, make sure you go see Mr. Fierro, or maybe Mr. Perkins can help. If you're still a little confused, you might want to watch this lecture again. This is a simple concept we're introducing. The problem is always going to be, though, when I give you these in word form, you're going to have to convert them and then tell me what type of reaction it is. Which actually, since we've got extra time, at least according to my clock we do, let's go ahead and practice one of those. Okay, just because we've got extra time. I don't want to leave you guys hanging and have only a half hour for you to do, so that you have to be entertained for the next 15 to 20 minutes. Alright, so let's say I'm going to give you a reaction, and then I want you to write it, balance it, and tell me what kind of reaction is happening. Alright, I'm going to try not to pick one that's horribly difficult. Alright, so let's say we've got strontium. Alright, strontium plus let's go with potassium. Strontium plus potassium. Sorry, I gotta zoom out so this fits on the screen. Strontium plus potassium sulfate. Strontium plus potassium sulfate. I might have zoomed out a little too far. Let's write it on 2 lines. Makes strontium sulfate. Strontium plus potassium sulfate makes strontium sulfate plus potassium. Alright, let's go with that. So what I want you to do is write it in formula form, balance it, and then tell me what kind of reaction it is. The kind of reaction you actually, I'm sure, have already been able to figure that out just based on what's happening. Let's go ahead and do this in the order of deciding how to write it first, balance it, and then decide what type of reaction. So, strontium. Symbol for strontium. Obviously we know that's Sr. Okay, and it's just strontium all by itself. A couple things to ask. Strontium, is it part of Brinkelhoff? No. So really only one thing to ask. If it's not part of Brinkelhoff, leave it alone. Okay, just write it just like that. So strontium plus potassium sulfate. Is this ionic or covalent? Please, for all that is good, you should be saying ionic, right? It's an ionic reaction. So we know we need to look up charges, find out what sulfate is, and cross them over. So we know potassium's charge, if you look it up, is a +1. Good. What is sulfate? So regular, you guys can look it up, regular chemistry. For honors, remember your sentence, unless you've just opted to just straight memorize them. From your sentence, you have the word supper. So we know it's SO. How many oxygens are attached? 1, 2, 3, 4 oxygens attached, right? And what's the charge? Well, the U and the E, right? So 2 minus. So you're putting together potassium with its +1 and SO4 with its -2. So remember, the 2 goes to the potassium, the 1 goes to the sulfate. Just crossing over. So you get K, which is potassium, 2 SO4, and that's just 1, so you leave it just like that. Good? On the other side, now we've got strontium sulfate. And again, what type of reaction is that? Should be very easy now for you to figure out that that's an ionic reaction. So, we already figured out what sulfate was, right? We did that right here. We already know sulfate is SO4 with a -2 charge. Sorry if you can't see that. Let's zoom in a little. Not my best handwriting, but it's SO4 with a -2 charge. And then what is strontium's charge? Because obviously if it's ionic, we need to look up both charges. What's strontium's charge? Good. Hopefully you're thinking or saying +2. So we've got strontium with a +2, SO4 with a -2. What do we know when they're both 2s? Hopefully you are saying or thinking, oh, we know that their charges just cancel out. We don't write either one, right? So we would just put them together then. So we're going to write them together. It's SrSO4, right? Strontium sulfate, charges cancel. And then plus potassium, we know potassium's K. Is it part of Brinkelhoff? Is K part of Brinkelhoff? Hopefully you are saying no. It sounds like it might be, but remember Brinkelhoff, I'm going to write it off to the side up here, is BRINCLHOF, right? So this is where your K sound is coming from, the Cl. So potassium's not part of Brinkelhoff. So leave it alone, just like that. All right, so we've got Sr plus K2SO4 makes SrSO4 plus K. I told you these problems can take a lot of time when you're writing out and balancing. So now our next step is to balance. So I'm going to try to do this without writing everything out. If you're still writing everything out, that's fine, but I want you to try to work on getting out of the habit of writing everything out. So, just because it'll take you too much time on a test. So, Sr, how many strontiums on this side right now? Good, 1. And on this side? 1. So those are fine. How many potassiums on this side? Hopefully you said 2. And how many on this side? 1. So what do I need to do to fix that? Good, we're going to put a 2 in front of the potassium on the product side. So now 2K, 2Ks. Last thing to check, remember our rule from balancing. If the polyatomic ion stays together, treat it as just one thing, right? So we have SO4 and SO4. Sulfate stayed as sulfate, so don't break it up into sulfur and oxygen. Treat it as just one thing. 1 sulfate on this side and 1 sulfate on that side. So we're actually perfectly balanced just by adding that 2 right there. So again, you can leave these lines blank if you want to, or you can put 1s in front of everything. Last and easiest, what type of reaction is this? Hopefully very simply you see the strontium came in and kicked potassium out. So we know this is our home wrecker reaction, or the more chemical way of saying it is our single replacement reaction. Right? That's it. I mean, we could keep doing examples, but I don't know if that's entirely necessary. You guys are going to get some practice on this. Make sure you can do the practice. If you're still confused, YouTube, Google, do whatever you have to do to learn these types of reactions, alright? Miss you guys, and don't worry, I'll be back soon. Hopefully you're hanging in there. Hopefully you're being nice and good and not being stupid, because I can call you that because I'm not there. Hopefully you're not making Mr. Perkins' life more difficult, because you shouldn't be, because he's doing us all a very big favor by being there. Alright, so be nice. If you have any questions, make sure you find someone who can help you. That's not me, but make sure you can find someone who can help you, okay? Have a fantastic day.